Morning, everybody. Starting a new chapter here, chapter 6. This is motion in 2 dimensions. First topic of the new chapter is projectile motion, and it can be one of the more tedious concept to try to figure out because there's a lot going on here, but never fear, we'll get through this here. All right, so there's my poem for the day. All right, so a projectile, first of all, any object that is shot through the air. Projectile can be anything that you throw at somebody or with somebody, or whatever the case is. If you're playing catch with a baseball, softball, what have you, that ball is a projectile. If in class your friend says, "Hey, can I borrow a pencil from you?" and you toss the pencil through the air, that pencil is a projectile. Now, the trajectory refers to the projectile's path through space, and it's described as parabolic. The trajectory describing the path that the projectile takes as it travels through the air. So when you throw, you're throwing the pencil, whatever the case is. A parabola, it's described as parabolic. And parabolic, in other words, parabola, referring to describe the trajectory of the projectile as it moves through space. Again, space is just the atmosphere, not like outer space, just so we're clear on that. Now, one thing that we need to keep in mind as we work through projectile motion is this idea of the idea that the horizontal motion of a projectile does not affect the vertical motion of a projectile and vice versa. Okay, so what this is showing here, and I don't know how well you can see this, but we have, this is obviously from the textbook, the one ball here is just being dropped straight down. All right, gravity's pulling it, it's in free fall. This other object was given, the other ball rather, was given an initial horizontal push, and it is also, of course, in free fall. But you notice here, and this is done with a special camera, and so what's happening is they're showing that, I don't know if you can see the horizontal lines here, but it's got the images of the two objects basically being on parallel to each other, showing that the independence of the vertical motion relative to the horizontal motion. Okay, now, a projectile motion problem always consists of 3 parts. First of all, you're going to be provided with 2 bits of information. Number 1, you're going to know the launch speed. It might also say initial speed, but it means the same thing. And you'll also know the launch angle. Now, 3 things you're always calculating. Hang time, maximum height, range. Pretty much in that order, except like maybe one exception that we'll see later on in the chapter. But you calculate the hang time first, maximum height second, range third. Now, to do that, the hang time formula looks like this. T equals 2 times v sub y over g, where v sub y is v sub I times sine theta. So we just do a substitution thing. All right. You always know what, because v sub y by itself is just telling you the velocity in the vertical direction. Well, the angles, there's an angle here, so that's why we have the trigonometric ratio. So we have to include that as well, so we just substitute. So really, here's the equation you want to use. T equals 2 times v sub I times sine theta over g. Plugging in the numbers here, we've got 2 times the launch speed, which is 24, times the sine of 70 degrees, which is 0.940. Remember, your calculator should be in degrees and not radians. A lot of times the default setting is radians, so before you start this worksheet, make sure your calculator is in the correct mode, which is degrees. So if you go 2 times 24 times 0.940, you're going to get, and then divide that by 9.8 to get 4.6 seconds. Invariably, sometimes people forget to account for gravity. And if you don't account for gravity here, if you just say 48, 2 times 24 is 48, times 0.940, that's 45.12. You can't tell me a ball is going to have a hang time of 45 seconds. All right? There's no way. So you have to remember to account for the acceleration due to gravity. Once you do that, you get a more reasonable answer of 4.6 seconds. That's okay. That's good. That's good for hang time. Now, you got the hang time figured out. You've done it correctly. Good. Move on here. and we'll take a look at maximum height. The maximum height formula, y sub max equals v sub I times sine of theta times time minus 1/2 gt squared. Got all that? Don't worry, the formula is always provided. You don't have to memorize formulas ever. I'm sure you figured that out by now. If not, now you know. Okay, so plugging in the numbers here, and you have 24 times 0.940, so launch speed times the sine of the angle times 2.3. Wait a minute, the 2.3, what's the deal with that? We said the hang time was 4.6. Well, remember, think about this. An object, all right, if the object, here's the wiffle ball, if it is in the air for a total of 4.6 seconds, all right, that's the hang time, then it reaches its maximum height at half that, which is 2.3 seconds. All right, so that's when the ball is reaching its maximum height at half the hang time. So we have to account for that. So don't use 4.6 here. Use half that. Whatever the number is up here, divide it by 2 and plug it in here and then over here as well. Notice that over here on the end, the time is squared. So just kind of go back through the entire equation. Launch speed times sine of the angle times 2.3 minus 1/2 times gravity times 2.3 squared. Sometimes people forget to square the time out here, and that messes you up. Sometimes, for whatever reason, your calculations are wrong. You get a negative number. If you get a negative number for maximum height, you got to really think. Oh, wait a minute, something isn't quite right here. Go back, see if you can figure out where the error is. I'll tell you what. If I had to guess, I would say 90% of the time, the source of the error is the fact that this number doesn't get cut in half. All right, it's 4.6 up here. Remember to cut it in half when you're dealing with hang time, with maximum height rather. Okay, there's 4.6 for hang time. The maximum height is 2.3. All right, the time is 2.3. So you plug all the numbers in, and you could solve this over here, solve this over here, and then subtract the two, or just type in everything at once. You know yourself best, and you know your calculator better than I do. So whatever works for you, just don't forget to square the time out here. When you do all the math, you get 25.97 meters. All right, so we got the maximum height figured out. Now, for the range, notice we're going to do a little substitution again. We've got x equals v sub x times t. V sub x equals this, v sub I times cosine of theta. So we do the substitution. Here's where a lot of people run into trouble. They forget when they substitute, they don't account for the time. All right, because it just gets kind of left out. Always remember to account for the time. Because, let's face it, I throw the ball here, I'm going to throw it at the fume hood, you'll hear it. Okay, you'll hear that. It takes time for the ball, once it leaves my arm, my hand rather, it takes time to get there and then bounce back or whatever. But we're looking at that horizontal distance between where I launch the projectile and where it lands. Right? That's when we're talking. We're talking about the range there. If I could just spit that out and tell you. All right. So once we have the times in place, that we've accounted for the time, you do 24 times the cosine of the angle. All right, so again, your calculator's in degrees, and then also you have the time here. All right, notice the time is the same as hang time. All right, it's the same value. It's not cut in half for the range. It's the whole value. So just bring that down. Then multiply the three numbers together. 24 times 0.342 times 4.6 gives you an answer of 37.76 meters. Guess what? You figured out the range. You're done. Now, some of you will prefer just move on to the next problem, whatever. That's fine. Others of you, you think about this like, okay, I need to bring all this together. I calculate this first and this and this. What the heck? So what I did here was I brought all this together in a very rough schematic because, well, let's face it, I don't teach art. Okay, so we have the hang time. Hang time here is total of 4.6 seconds. It's 2.3 seconds from the time I launch until it reaches its highest point, and then another 2.3 seconds until it hits the ground. The maximum height is 25.97 meters. This is your range, 37.76 meters. All right. This kind of helps you just kind of bring everything together. You don't have to do this. You don't even, I mean, if you want to, just for your own benefit, you're certainly, I'm not going to object. But, it's just a tip that I found that seems to work for some students, just to kind of help them bring everything together. But, again, you don't have to show me the schematic or anything like that. All right, so just to kind of wrap things up here, we've got projectile, we've got a trajectory, and that projectile's trajectory is called a parabola. Again, some of you may know that from your math class. Algebra 2, maybe Algebra 1, I don't know. But anyway, calculate the hang time first. Again, substitution. All right, and then I'm showing you how I substituted. Then I plugged in the numbers. Then I solved. Maximum height, no substitution here. Just remember to take the hang time, cut it in half for time here, and then over here as well. Make sure you square the time on the end. Get your answer. And then the range, don't forget to account for the time even after you do the substitution, because again, a lot of people forget about the time here. Launch speed times cosine of the angle times the time rather than hang time, times the hang time, multiply three numbers together, and you are good to go. So, hopefully you find this video useful. If you have questions, please email me. Everything's posted, and of course this video will be posted shortly in Google Classroom. I recommend you do not wait until the last minute to try to do this worksheet, because you're going to probably end up not having a good experience with it. Something else to consider is question number 3 on the projectile motion worksheet. I want you to basically analyze the data. So, you're going to compare like, okay, well, if I increase my launch angle, instead of 70 degrees, if I make it 79 degrees, if I do that, what does that do to my hang time? What does that do to my maximum height? What does that do to my range? All right, so you're going to do a little comparison there. Don't leave that statement blank. I do want you to take some time and think through that question. How would you answer that question? Not looking, write a complete sentence or two and be done. Move on. And when you define formulas, or write out formulas rather, make sure you define all the variables. Honestly, you're going to write 3 formulas. You only need to define the variable one time. But I do want you to have all 3 formulas there, because that's going to help reinforce, make sure that you at least recognize the formulas. So good luck with that worksheet. If you have any questions, as always, let me know.